Hello everyone, welcome back to our YouTube channel. My name is Nikhil and today we'll be solving questions from LeetCode's weekly contest which is LeetCode 400. So let's dive into the video with the first question. Minimum number of chairs in a waiting room. So let's see what the problem statement is saying. So you are given with a string S. So you need to simulate the following events at each second I. So what are the events that will happen at each second? So one is this and the second is this. So let's see what first one is saying. So if S of I is equals to E, that is nothing but the character this index is E. That means a person enters the waiting room and takes one of the chairs in it. And if the corresponding ith index character is L, a person leaves the waiting room freeing up a chair. Now our objective is to return the minimum number of chairs needed so that a chair is available for every person who enters the waiting room, and we can assume that initially the room is empty. So let's try to understand the problem statement with the given examples. So in the first example the string is this. So let's try to see. So what is the explanation is saying? After each second a person enters the waiting room and no person leaves it. So therefore the minimum number of chairs needed is 7. So it's pretty straightforward, right? Enters, and every person is going to occupy at least one of the chairs in the waiting room. So the output is 7. So let's move to the second example. What the second example is saying? Let's consider that there are two chairs in the waiting room and the table below shows the state of the waiting room at each second. So they are assuming that initially there are two chairs in the waiting room. Okay. So let's move forward with that assumption. So available chairs. So if you see in the string, I'll write the string here. The string is E, L, E, L, E, and L. So now at this index, as you see E, he enters the waiting room, right? So as soon as he enters, he is going to occupy one of the available chairs. So previously we assumed that there are two chairs. Now the total available chairs are 1 because there is one person who entered the waiting room and he occupied one of the chairs. So similarly, if you see here it is N. That means this person has left. Now the available chairs are 2. So when we move forward, there is one more person who entered the room. Now if you see again the available chairs are 1. So people in the waiting room are 1. And this person has occupied one of the available chairs. So moving forward L. That means this person has left. That means at this instance we have the available chairs as 2. Again moving forward, he entered, right? He entered, so he's going to occupy. So now the available chairs are 1. Again moving forward, this person hasn't left yet and there is one more person who entered and he is going to choose this available chair and the total available chairs are 0. Again moving forward, if you see this L, one of the persons will be left, right? So at this instance the available chairs are 1. So with this tracing you have understood, right, how we got the answer as 2, because when this person entered, he is of course going to occupy one chairs, right? He's going to occupy one of the available chairs. And again, when this person entered, he hasn't left, right? So he's going to take one more chair in the waiting room. So what is this? 1 plus 1, right? So at max, you need two chairs to meet this criteria. What is this criteria? So that a chair is available for every person who enters the waiting room, right? So I can say that 2 has the minimum number of chairs to meet this criteria, right? So let's try to understand it better. So at this instance, can I say that total occupied chairs are 1? Can I say that? Yes, I can say that. Now at this instance, what is this L, right? So that means this person is leaving the room. Now at this instance, can I say that total number of occupied seats are 0? Yes, I can say that because this person has left. And at this instance, can I say the total number of occupied seats are 1? At this instance, can I say it as 0? Yes. Now at this instance, can I say the total number of occupied seats are, can I say the total number of occupied seats are 1? Yes, I can say. Now at this instance, he is going to occupy one of the seats, right? So at this instance it is going to be 2 because he is going to occupy one of the seats and he is going to occupy one of the seats. So it is 2. Now as one of the person is leaving from these two, can I say it as 1? Now how can we get 2 from this? Can I say it as maximum of all the occupied seats? Can I say that occupied seats at each instance? Maximum of occupied seats of all instances, right? So the problem breaks down to maximum of occupied seats at all instances. So here the max is 2. So we end up printing 2, which is expected, right? Now how can I put this into code? Now how can I put this understanding into code? If S of I is equals to E, that is the person is entering, can I say that occupied plus plus? Yes, otherwise what can I say? Of course we know that string only consists of E and L. When if it's not E, of course it is going to be L. Now can I do occupied minus minus? Yes, right. While doing this, what should I do? I should keep track of maximum value for this occupied. So after this, I will keep a track of the maximum value, that is maximum of, let's say let's call our answer as answer comma occupy, right? So at the end we can return answer, which is our desired output. To better avoid confusions, let me write it as OCC only. So if this logic is clear, let's jump into submitting this code. So we are given with string s, right, as the input. Now we have seen the logic, right? So I'm declaring a variable OCC and I'm initializing it to 0 because initially the room is empty. Now I will run a loop, right? I will run a loop over the string. Now what should I check? If character is equals to E, that means a person is entering the room, right? So I should increase my occupied seats. Else that means he is leaving the room. So at that instance, occupied seats decrements by 1. At each step, what should I check? The maximum value of occupied, right? Let's assume that we took an answer variable and initialize it to 0. Now at this place, what should I check? Answer equals to math dot max of answer comma occupied. So at the end, I will end up returning answer which is expected. Let's try to run and see the output. If it's getting accepted or not. So it accepted for the sample. Let's try to submit and check for the internal test cases. So it got accepted and it beats 100% of the users, which is the most efficient solution, I think. So let's dive into the second question. So here is our second problem statement, and the problem statement name is count days without meetings. Let's try to understand the problem statement. So the problem statement says that you are given a positive integer days representing the total number of days an employee is available for work. Okay, starting from day 1. So you should start counting from day 1. So you're also given a 2D array meetings of size n, where meetings of I represents start time and end time of that meeting, of the ith meeting. Okay, so that's what they are saying, represent the starting and ending days of the meeting I inclusive. So our objective is to return the count of days when the employee is available for work but no meetings are scheduled. That means you should only return the number of days when he's only working and not attending any meeting. And they are saying that the meetings may overlap. The meetings may overlap. Let's try to understand the problem statement with the sample input outputs. So what is the example one here? So they gave days as 10 and the meetings as 5, 7, 1, 3 and 9, 10. And here the output is 2. What is the explanation? There is no meeting scheduled on 4th and 8th days. Okay. Okay. Let's try to represent the in a number line. So to better visualize the problem statement. and 10. So what is the first interval saying? So there is a meeting from 5 to 7. And what is the second interval saying? There is a meeting from 1 to 3. And what is the third interval saying? There is a meeting from 9 to 10. And there are 2 days, that is 4 and 8, on which there are no meetings scheduled. So we should return. So it is 1 and this is 1. So you end up returning true as the output. That's what the expression is saying. There is no meeting scheduled on 4th and 8th days. So how will you approach this? What can be a simple approach? What can be a simple approach? You can take a list or vector, you can add all the days from 1 to 10 and you can perform a linear search on them, and for some value, if you don't find it in this range, you increment your days and you return days at the end. So but if you see the constraints, for these constraints it is going to result in TLE, right? So how can we optimize this further? So now what will I do is I will try to sort the meetings in ascending order of their start time. So if I do this, how will the matrix will look like? So it is going to look like 1 comma 3 followed by 5 comma 7 followed by 9 comma 10. So this is how the matrix is going to look after I sort them in ascending order of their start times. So but with this, how can we optimize our solution? So we don't need to worry the values between them, right? We don't need to worry about 2, we don't need to worry about 6 and nothing here. So we don't need to worry about these values, but we need to worry about the values between them, right? So what is the value between them? 4. And what is the value between them? 8, right? Now what is this? This is the ending time. And what is this? 5. This is the start time. So this is the ending time of the previous meeting and this is the start time of the next or the current meeting. Okay. Now, how can I get the value that is 1 here for the value 4? How can I include 1 to my answer? So if I give you this range, how will you find the number of values between them? Both 3 and 5 inclusive. Inclusive. How are you going to do that? So if you treat this as A and if you treat this as B, the total number of values between A and B both inclusive is B minus A minus 1, right? So if now this will turn out to be 5 minus 3 minus 1, which is 1, right? Now again let's try to see for the next two intervals. Now again for this interval, what is this? This is the end time and this is the start time. Now again, how can I get the values, all the values between them? How can I get all the values between them? I can get all the values between them by 7 comma 9. Now I'm going to apply the same simple formula, that is 9 minus 7 minus 1, which will give us 1. So if I add them, it will result in 2, right? That is 1 plus 1. So this point is clear. But is this logic handling all the cases? So what am I doing actually here? For the current meeting, I'm trying to get the end time of the previous meeting and I'm trying to get the values between the range, right? But will this work for all the cases? Let's try to check. So what they have mentioned here, they mentioned that meetings may overlap, right? So if you see, this example is a case for the overlapping. So let's try to represent this on a number line. Okay. Now if I write the values, that is 1, 2, 3, 4, and if you see the days, it is 5. So we also have the 5. Now 1 and 3, right? So let's write for 2 and 4. So 2 and 4, and next 1 and 3. 1 and 3. Now if you see, the intervals are overlapping, and you don't find any value between them which is free, right? But how we got 1 here? How did we get 1 here? That is 5 minus 4, right? 5 minus 4 gave us 1, right? 5 minus 4 is 4. 5 minus 4 gave us 1. Now with this, what did you understood? What did you understood? Even in case of overlapping intervals, we should keep track of the last ending value. And even here as well, even if the intervals are not overlapping, still you need the ending value, right? This ending value will act as the lower limit, right? It's a lower limit in our range. So you should keep track of this. Even for this is going to be the lower limit here, that is 3. So you should keep track of the ending, and also you should keep track of the last ending to handle this case. We already saw that we are going to sort the array with the ascending order of the start times, and we know how to get all the values between the range, that is between end and start time of the current meeting. But is this relation be valid for all the values of A and B? So let's try to check for this. So first of all, we have sorted according to the ascending order of the start time, right? So that is 1 comma 3 and 2 comma 4. Now for this interval, this is going to be your end and this is going to be a start, right? Now can we say that there will be some values between them? Can I say that? No, right? I can't say that, right? I can't say that. But here, if I give you something like, now for this is going to be your end and this is going to be a start. Now for this 3 and 7, for this 3 and 7, can I say there are some values between them? Yes, I can say. How? So first of all, what are the free days here? So it is 4, 5 and 6. And if I apply the relation here, it is going to be 7 minus 3 minus 1, which in turn will give me 3, which is 4, 5 and 6. But how did I come to this conclusion? So for some values to be valid within this range, right? For some values to be valid within this range, these values should be greater than this and these values should be less than this, right? Yes. Now, now here, here, do you have any values which are greater than this and less than this? No, right? And if there is at least one value between them, I should include that value to my answer, right? Let's say instead of 7, assume that you have 5 here. So there is at least one value, right? There is at least one value 4 which I can consider it as a free day. But how did I come to this conclusion? How did I come to this conclusion? How did I actually come? Because start is greater than n plus 1. See, this is your n, right? This is your n, and this n plus 1 is stating that there is at least one value between them which I can include them that to my answer. We can also have many values. So previously here it was 7, right? Now here it is 7, and what is your n? 3, which is 3 plus 1, which is in turn 4, right? Your 7 is greater than 4. Then I can say with this formula there are these many values between them which I can consider as free days, right? Now we have covered all the cases here. Let's try to put them into code. So let's jump into the code. So first of all, I should sort the meetings array according to the start time of the meetings, right? So I am doing that with this one liner. For any two meetings, compare the start times. Now this will give me the sorted array according to the start time. Now I am taking two variables. So f days will take the number of free days and last end will give me the last meeting's end time. Right now it is 0 because for the first meeting you don't have any previous meeting to compare with. Now you start your loop and you iterate over the meetings. Let's write for each. So meet meetings. So what will meet give you? It is going to give you start time. It will also give you the end time. Now when can you calculate the free days between any two intervals? Your start should be greater than end plus 1. Then you increase your f days with start. So is it end or is it the last end? So you should compare your current meeting with the previous meeting's end time. So it is the last end. So you get your number of days between the range by b minus a minus 1, that is start minus last end minus 1, and current meetings end will be the next meetings end, right? Current meetings end will be next meetings last end. So I'm going to update that here. Last end equals to math.max of last end comma end. And we already discussed it, we are taking max because there might be an overlapping intervals. And what if the case is this, if the last end is less than days, what should we do here? We still got some of 3 days left, right? So I'm going to get them by days minus last end, right? Now what should I return at the end? I should return f days. So I'm running the code. So it got accepted for sample. Let's submit and check. It got accepted, right? So yeah. So let's dive into the third question. And the problem statement is lexicographically minimum string after removing stars. Right? Let's try to understand the problem statement. So you are given with a string S. It may contain any number of stars. They are saying it may contain any number of asterisk characters. Your task is to remove all the asterisk characters until and unless there is at least one star. Delete the leftmost star and the smallest non-asterisk character, that is non-star character, to its left. If there are several smallest characters, you can delete any one of them, right? And the objective is to return the lexicographically smallest string after removing all the asterisk characters. For each asterisk character, you perform this operation, right? Now let's try to understand it in a better way by looking at the examples they have provided. So in the input string S, you have this, right? So for this star, as soon as you remove this star, you are going to search for the lexicographically smallest character on its left, right? And you found A as the lexicographically smallest. You end up deleting both of them, and the resultant string is AAB. And moving to the second example, there is no stars, so you're not going to perform any operation here. So you'll end up printing ABC, right? So here, coming to the first example, what did we actually saw? So for this star, you have moved towards left, right? And you have removed first smallest character. So for every asterisk, you can iterate on its left and you can perform this operation, right? But will this solution work for the given constraints? No, right? This is going to result in TLU. How do we optimize this? So first of all, what are all the possibilities I have here? So for this star, to remove the lexicographically smallest character, we have 3 choices, right? So if we go with this choice, what is the string that I get? I'm going to get AAB, which is the lexicographically smallest. Now if I remove this A, what am I going to get? I'm going to get ABA. Now if I remove this, what I'm going to get? ABA. Now out of all these combinations, this will give us the lexicographically smallest possible string, right? But let's try to work on this for some different example. Let's say there is some string S which is something like B, A, D and star. Okay. Now for this, what you're going to do? As soon as you see this star, what will you do? you'll iterate on its left and you'll delete the smallest character. So what is the smallest character here? It is A. You're going to return, you are going to delete D and you're going to remove this and you will return BD, right? You're going to return BD, which is the lexicographically smallest possible, right? Now, here to optimize this, what will I do is, to optimize this, what will I do is, to optimize this, let's try to have an observation. So when you have A, of course you are going to remove A, right? Unless and until all A's are removed, you are not going to touch B, right? This point is clear. So what will I do is, so for this character, are you going to perform any operation? No. For this character, are you going to perform any operation? No. 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 When you are here, you're going to search for the smallest character and you're going to delete it, right? Now, before going to this character, what will I do is, I will assume some data structure. Let's come to this data structure at the end. So I will assume there is some data structure, and when I found this A, I will put A in this data structure. And when I found this A, of course I'm going to put this in the data structure. And when I found B, should I put B here or here? First of all, I should remove all occurrences of A, as A is the lexicographically smallest character, right? So now where should I put this B? Once I remove all the A's, then only I can remove B. So I'll put B here. Now when I move forward, I found A, I'll put it here, right? Now when I found this star, what will I do? I'll come to this data structure and I will remove this A. Now what will I do? What will I do? What can I do? I can pop this, I can pop this, I can pop this, right? It's matching with the output. Let's see if this matches with the example that we took here. So this was the example that we took, right? This was the example that we took. Now let me write it. String S BAD star. Let's see if it's working for this example or not. So for this, what is the output? For this, what should be the output? Our output should be, when you delete A, the output should be B and D. For this star, you remove A, right? Both of these characters will be removed and B and D will be the output. Let's see, let's do the same thing what we have done for the previous example. So assume that there is some data structure here which will do the which will do our requirement here. Okay. Now when you found this B, you're going to put B, right? When you found this A, you should first remove A before removing B, right? So you put A here. When you are at this D, are you going to put D here or here? So lexicographically, first character that can be removed is A, then B, then you can go for D, right? So you put D here. Now when you find this star, you are of course going to remove this, right? Assume that you have removed this, right? Assume that you have removed this. Now what is the output if I remove this? You are going to pop B and you're going to pop D, right? You're going to pop D. Now let's see if this is working for some other examples. So now the string is, assume the string is C A B star, right? C A B star. Now what should be the output? Our output should be, for this star you are going to remove A. So output is C and B. Assume that again there is a data structure which will do our work. Okay, there is some data structure here. Now you see C, you put C in this. Now when you see A, you are going to put it at the first place so that it can be removed. Now when you are at B, where are you going to put your B? You're going to put your B. Where are you going to put your B? Where exactly you place your B? So first you find A as the lexicographically smallest, you remove this. Now after A, what is the possible character that you can remove? That is B, right? So you put B here and C comes here, right? C is the lexicographically greatest in this string. That should be removed at last. Now when you are at this star, what do? You iterate and you pop A, right? You pop A. So this A is removed. Now what will you do? You will pop B and you will pop C, right? Now is this the answer? Is this the answer? Is it matching? No, right? It's not matching. Now how can we fix this? Now before moving to fix this part, what can be your data structure here in this case? What do you actually want at each step? You want something minimum, right? You want something minimum, and which data structure will help us to get something minimum in an efficient way? Exactly, right? We can go with priority queue, which is also known as a mini heap, right? So mini heap will always store minimum at the top. So you are going to store A followed by B, and so on until Z, right? So we are finalized with our data structure. Now let's move to fixing this part. Now is popping directly from the data structure helping us, or popping directly from the priority queue helping us? No, it's not helping. Now what are we storing in the priority queue? We are storing the characters, right? A followed by B and so on. Now what if we store the index along with the character? Will it help us? Can we store character along with its corresponding index in the string? Will this help us? Okay, let's try to check. Now what will I do is, now let me give the indices here. So it is going to look something like 0, 1, 2 and 3. Now as soon as I see this C, I'll put C here. I'll put C along with 0, right? Now as soon as I see 1, I'll put A with 1. Now as soon as I see this B, I'll put B with 2. Now as soon as I see this star, I will have A at the top, right? I'll have A at the top and I'm going to remove this, right? I'm going to remove this. So instead of removing this directly, what will I do is, after removing this, I will make sure that I mark this index character with some value. Let's say underscore here. Now, when I'm printing, I will handle this underscore and I'll print it. So whenever I see an underscore, I'm not going to consider that character into my output. So when I'm iterating, I will not consider when my character is an underscore and when my character is a star or dash, whatever it is. It can be some terminating character. We can treat this as a delimiter. Now, is this equal to star or the underscore or hyphen? No. I can just go with C. Now, is this equals to delimiter or star? No. Now, is this equal to delimiter or star? Yes, that's the reason I didn't include it to my output. Now, is this equal to delimiter or star? Yes, this is equal to star. I'm not going to consider that character to my output. Now, will this work for all the cases? Okay. Now, assume that, let me slightly modify this test case. Okay. Now, I'm taking the string here again. But now the string will look something like this. Now, what happens to data structure? How will you insert the data into data structure? It is going to be C and 1, then A and 1, followed by B and 1, Now again you found an A, right? So what happens? You're going to insert A comma 2. As practically by default sorts it in the ascending order, you're going to have A comma 2. Sorry, this is 0, 1, 2, 3, 4, right? So C comma 1, then C comma 0, then A comma 1, then what else? B comma 2, then A comma 3, right? Now with our previous approach, what is the character that is going to be popped from the priority queue? This A, right? With index 1. Now you come to index 1 and you mark this character with some hyphen. Assume you have marked with some hyphen. Now when you're printing your output, what you'll do? You'll print C, as this is hyphen you will not consider, and you see B and you see A, you pop it, right? You pop it and you see A, right? But is this the expected output? For this star, you should remove the smallest character to its left. What is the smallest character to its left? That is this A, right? When you remove this A, the output will look something like CAB. Are they matching? Are they matching? No, they are not matching. Now, how do we fix this? How do we fix this? Now I can slightly modify my data structure to something like when I have same characters, I want the bigger index to be at the top. So I will modify or I'll define my data structure in such a way that it will have a comma 3 at the top followed by a comma 1 at the ending because this is the first character that should be removed, then followed by this character, then followed by this, and so on. So if this logic is clear, let's dive into the coding part. So if you see, I have declared a class pair which is having both character and the index, and I have declared a min heap here, and I am sorting accordingly. So first of all, if the character is same, then I am sorting according to their indices, and if the character is not same, then I am going according to the ascending order of the characters. Now first of all, what should I do? I will declare a character array as I will manipulate the character array. Now I should iterate over the string. I can do that by writing a loop ch.length and I plus plus. For each character, what should I check? If character of I is equal to star, what should I do? I should pop the top element of the priority queue, and I can only pop if the priority queue is not empty. Otherwise, it will throw a null pointer exception. So I will check if priority queue is not empty. If it is not empty, then what should I do? What should I do? I can pop it. So before popping, what should I do? I should mark that index. That is nothing but I should mark the top element's index as null character. I can get that by index, right? P gives me the top, or else I can directly use the poll here. And when I'm polling it, that is when I'm removing it, I'm getting the index of the character that is being removed, that is the top, and I will mark it as a delimiter character. That means indirectly it is removed, right? And else that is nothing but it is some other character other than the star. So that now I should add, right? I will create a new pair and I will add ch of I along with the index, that is I, right? Now at the end, what should I do? Now I will create a new string, that is result. Now what should I do? Now I should iterate over the character array, right? Now what should I check? If ch of I is not equal to asterisk or star, and it should also not be equals to, it should not be equals to the hyphen, then only I can include the character into my result. I will do result plus equals to ch of I. That is nothing but I'm appending all the valid characters here. Now at the end, I can return a result. Now I'm running it. See, it's accepted for the sample. Let's submit it and check for the internal test cases. And it got accepted successfully. So this is all about LeetCode contest questions. Hope you guys had a great learning. This is it guys. Thanks for watching the video. If you liked our content, make sure you do like, subscribe and share our channel. See you in the next video. Bye bye.